Have a really great topic to discuss. And first of all, I want to thank you for choosing this track today. There is a lot of competition right now and lots of good stuff going in parallel. But bear with me, the next hour in this room 11 is going to be freaking awesome. We'll talk with you about APIs, we'll talk about GraphQL, and since we are in Riga in Latvia, I think this is the right way to call our talk. Jauna veida APIs, right? This is like the right way to call it. And yeah, I've figured out how my name and surname is pronounced in like written in Latvian, which is pretty cool. But let's get to it. So first thing I want to mention to you is that GraphQL is not really about the databases. I've seen people thinking that maybe GraphQL is more about database access. It's really not. It's about APIs. And before we continue, let me ask you, who have heard about GraphQL before? Okay, and who is using it in production? I don't see any hands. Okay, cool. So I really hope this talk will be useful for you. You know, on one of the conferences, there was like a classification of the complexity of the talks. And my talk is going to be a smoothie. Do you know the smoothie drink? So it's going to be a smoothie today. And I will make sure, I will try my best that this smoothie for you tastes well and is also useful. So my name is Volodymyr. I'm coming over from Ukraine here and send you hi and hugs from Ukrainian IT community. I'm working for the company which is called Wix. I am head of development in one of the departments in this company which is dealing with money. So we pretty much know what is being responsible for the stuff that we're doing. A part of that, I'm also a partner at EasyHunt. EasyHunt is a startup which is dealing with hunting, pretty popular in Sweden, Norway, and other like countries nearby. And also I'm the program committee of GConf, XP Days, and now DevOps conference, which will be held in 2019 for the first time. Anyone heard of GConf or XP Days? Okay, just a couple of hands. These are really cool conferences related to Java development and also related to like extreme programming practices and in general about iterative development. Company Wix. Anyone heard of you about Wix before? Okay, several hands. So Wix, we have a lot of users right now. It's like over 125 million who are creating sites. Sites of different purpose and of different complexity. It can be very simple sites, it can be online stores, it can be booking systems, but it can also be the sites which are actually dealing with code. So you can write code for backend and frontend, and which will work in the serverless environment. I don't know, I think it's around billion users who are actually visiting that site. So we have a lot of customers here, and also you can see we have like 700 engineers, approximately the same number of microservices. So we are a microservices basically company. But I understand you're not here to listen about this shit. You're here to have some fun. And I want to show you something. So one of our users created a pretty interesting site, an online store, where you can adopt a unicorn. So let me go to Google Chrome, open unicornadoptions.com. Just think about it. Instead of going to Riga Dev Days, on Wednesday, you decide, okay, I will probably buy an unicorn adoption kit for me, probably for my wife, and we'll play with it. So I can go and adopt a unicorn. So let me find something. For example, I like this white unicorn combo pack. And in this pack, I can find a toy, I can find the postcards, the mask, the certificate, also badges, basically everything. I will add 2 of those to my cart. So here we go. I can view my cart and see the stuff that I have added before and can perform the checkout. So this is a very simple flow for the online store. And there are hundreds of thousands of these stores already created on top of the Wix platform. Each of those sites is not actually a separate system. So all of those sites are running on top of one backend with one set of supported clients and an API that connects the two. And let's think about the API. Let's think about what kind of API can we provide for such a system that will give us an opportunity to fetch data. Like, for example, for this page that you have seen before, we will need the product title, price, we'll need images, description, information, and some other fields. There are more than 20 fields for this particular resource that is being exposed, for example, via the get HTTP method using like a simple URL pattern. So everyone have done this before, right? Like very simple thing. Now let's move forward. Let's think about the collection of products. And in the collection of products, if you think about it, we'll have get/products, very easy. And the information that we need here is actually title, price, and a single image. I need just the headline image. I don't need all the images for this particular view. So if I am keeping my model simple, if I am saying that I will use the same model for the previous screen and for this screen, then I will eventually find out that I need just 10% of the overall payload from here. I am an engineer. I like to think about numbers and the actual effect that is taking, that like the user is facing. In this case, it's for me spending like 90% extra for serialization and for transmission over I/O. So the first problem that we hit if we keep our model simple is overfetching. So we have this really fat unicorn over here that is delivering more data that is actually needed. But let's move forward. Let's think about next use cases. So we have a cart, and in the cart, as you can see, which we fetch by getCart ID, we have items, and each item is referencing a particular product. There is a number of those products added to the cart. There is a total for every line item and the subtotal for the whole cart. So here, again, if we keep our model simple, then on HTTP layer, it may look something like this. We serialize this into JSON, we use getCart's ID, and we see just the references to every product. We don't fetch the product data. We keep things simple for now. But if we think about the effect for the networking here, we'll actually see that it will be 3 extra requests to draw that simple UI for the cart. So 3 for the products, 1 for the cart, 4 total. And at this point, if you think about it, if you think about mobile client, and it doesn't matter if it's a latest version of the iPhone or it's latest version of the Samsung or maybe Google Pixel, at the end of the day, it will drain battery faster and it will be really, really slow to draw that card. So the second problem that we hit is basically underfetching and the need for extra requests. Again, if we keep our resource model and resource structure simple. Of course, we don't do it. We create some kind of projections, or like they have different names depending on the framework, sometimes depending on like the choice of the HTTP API designer. But in this case, let's call it projection. So we say, okay, the cart will have a projection with products, which means that the product data will be embedded in the response of the cart. And then it will be a very special projection because only in this case, you can see the SKU number. In other use cases, it's not really necessary. So we create projection for summary of the cart, we create projection for the mobile, we create projection for the unicorns, okay? So we create lots of projections, and at the end of the day, we are hitting the following problem. It's hard to collaborate. Every time the requirements on the front end change, we are in the need to change the back end. Of course, we can do something more fancier, but in general, there is no unified and widely adopted standard here. I have put a star there, and later in the presentation, I will explain that there is a standard, just nobody is using that in the HTTP API world. But as a matter of fact, right now, I can say there is no really widely adopted standard in the community. And also, if you will take a look at this response structure, can you say which of those fields, as a backend developer, can you say which of those fields are used by the client? Anyone? Of course not. Like, you cannot say you took your DTO, you've serialized it into JSON, you passed it over to the client, and you have no idea which fields are used, how often they're used, how to apply deprecation policy to those fields. So the question that pops in your mind, how should I deprecate and phase out outdated stuff? Of course, I can start communicating with my clients and tell him, please, 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 don't use this field anymore. But you understand, you will have no way to track the usage of those fields in scope of that response. So I would say we have the following situation, okay? Everything is pretty cool, everything is pretty positive, and the weather outside is really great, we are in Riga, but something is not right in this use case. Something is not working well. So, and this problem was actually faced by Facebook in 2012 when they were developing their mobile client, and they decided to solve this problem once and for all. And this is like how the process looked like for them. It was pretty complex. They added a little bit of black magic, and at the end of the day, they got GraphQL. Back in 2015, they presented it on ReactConf conference for Node.js developers and client-side developers, and it was kind of a solution for that problem. So let's try to understand what is GraphQL. So per the Bible, per the specification, GraphQL is a query language for the APIs and the runtime to fulfilling those queries with your existing data. So sounds like pretty simple, but let's get to the bare bones of GraphQL. The first thing you do in GraphQL, you have to define the schema. So this is basically a typed schema. This is not just it's not just like raw types, raw scalars. This is like a real schema. For example, imagine the social network where you will have users. Users will have friends. Users will, of course, have name. So there is like already a graph over there from the user to the user. And the square bracket means it's going to be a list of things. And there will be a city, okay? So user will live in the city. And in the city will also know about its citizens, will have a name and the population. And basically, this is your graph. You have defined your graph. The type is a special keyword. This is like a Scala-like syntax for defining your resource structure. And so far, so good. But in order to enter the graph, you actually need some entry point. Like this definition is somewhere in the air. You need some way to enter your graph. And in this case, for example, we have defined the field user, which has an argument name, which suggests us that, oh, okay, I can find the user by name and the user will be returned to me back, and then I can ask for more data from the user. How the query will look like. So let's take a look at the query. I will say, as a client, I want to extract the user by name, for example, Volodymyr's unicorn. I want to see the names of Volodymyr, and I also want to see the name of the city and the population of that city. And this is how response will look like. So GraphQL server will return a JSON for me, and in the JSON there will be a data field. And contents of the data field is fulfillment of my request. And if you will take a look at the shapes of the request and the response, they're actually very, very similar. I am asking only for the stuff that I need at this particular point in time in one request. In case of HTTP, it's going to be HTTP post because the query can get really, really long, and using the URL is not a good thing in this case. But the major part here is that in between client and server, we'll see just one request for that query. So let's see how it works. I want to show you how that is supposed to work. I have here a graphical console. So graphical is a standard UI for running GraphQL queries against the server. And I will say I want to query data. I want to look up the card by ID. I know that ID of the card is 1. And I will look for items, and the items will have a product. Each product has a title, price, SKU. I'm interested to get an image, but only the first one. I don't need all the images. Every product is probably added to the cart with some particular quantity, and this line item has a total, and there is a subtotal for the whole cart. So here I have created my query, and if I run it, I will see in response under the data field everything I have asked for. You will see product 1, 2, and 3 with the fields that I have requested. Let's make a simple change. Let's, for example, ask just for the product IDs, also clean up all this stuff here, and just see the subtotal. In this case, I will see, again, only the products with their IDs and just the subtotal. So this is pretty cool. And if I will look at the network console over here, so you can see that this is just one simple post request against the server. So this is pretty nice. Let's summarize what we have seen so far. So this API is basically what you see is what you get. You are, as a client, you are asking for specific stuff and you're getting the specific stuff out. This is efficient because you're not doing any extra on the network level. It's easier to develop because once you have defined your resource structure, there is no need for the front-end developer to go and ask for something extra from the backend. Of course, if the model changes, if there are some new data pieces that must be exposed from the server, in this case, and probably only in this case, the backend will need to be changed. But in all other cases, you may have 10 views or 20 views of the same data. In this cases, you don't have to ask for any extra things from the backend developer. Analytics is easier because right now I can say my clients, from now on, I can say my clients, you know what? This field is deprecated. And since I see your queries, I can actually say if you are still using this field, okay? And if you will think a little bit further, for example, you have session keys for all your API clients, you can basically track who is using those particular fields and communicate with them. So this is really nice. And also, it works over any data source or transport. So basically, it can be HTTP. You can use binary protocol. You can use WebSocket if you need fancy stuff. And we'll look at the WebSocket example later on. So basically, a lot of good stuff. And there is a bunch of frameworks created on the server to deal with GraphQL. So who is here is using Java? Okay, so great. The follow-up examples will all be based on Java. And if you are not a Java developer, it will still be clear and easy for you to understand what is going on. But framework-wise, we'll concentrate on the Java world. By the way, any guess which language or for which ecosystem there is a most powerful GraphQL server out there? Any guess? PHP is not here, so it's really not. Of course, it's Node.js. JavaScript is taking over the world, and in this particular case, the best and most powerful GraphQL server that you can get is Node.js. By the way, I would say Scala is going second. We're using it in production. In Scala, a version of Scala reference implementation for GraphQL, which is called Sangria, is a very good example of a GraphQL implementation. Still not so powerful as Node.js, but still a good one. So in the Java world, there's a GraphQL Java, not a very fancy name, but speaks for itself. This is a reference implementation of GraphQL server in Java, and everything I will be showing now will have a live coding session. And of course, we need a microservice system here. It's 2018. Everyone is talking about microservices. Maybe you're already bored about talking about microservices. But at Wix, we're using microservices a lot. And the ecom system that I have shown to you behind the scenes is approximately 15 to 20 microservices, which are responsible for completely different areas of the ecom, of the online store. And in this case, I will use a simplified example. So we'll have a cart service, which is built on top of Spring. Any Spring users over here? Okay, cool. So many of you know about Spring. And we'll use SQL database to store the cart data. And there will be another service, which is a product service. And the product service will retrieve the data for the cart service, and the cart will speak to the product via HTTP protocol. You shouldn't care what kind of storage is behind the product service. It's not interesting for us. For us, it's the only important part is that it fetches data over HTTP. And we'll be now building a GraphQL API on top of the cart service for our clients that will enable requests like this, like we have seen here. So let's get started. Let's rock and roll. I have IntelliJ IDEA here. I will go to the presentation mode and we'll go to the beginning of times when there was no GraphQL whatsoever. And in here, in the beginning of times, the first thing I will have to do, I will have to add dependencies for GraphQL. So I will have 4 dependencies here. The first 2 is GraphQL Java and GraphQL Java Tools. You already know what GraphQL Java is. GraphQL Java Tools is basically a miscellaneous an utility library on top of GraphQL Java that allows us to build resolver functions for GraphQL. You'll see it in a second. Also, we'll have 2 Spring Boot plugins here. The one which enables us to write simple beans, simple components to expose GraphQL, to describe GraphQL things in our application. And graphical plugin is giving us this static resource, so this console that allows us to run queries. Okay, having these dependencies in place, the next thing I have to do, what every API on top of GraphQL starts with. We have defined this previously in one of the slides. We're starting with a schema. So there will be a schema here, and each schema has an entry point. We don't really care what kind of entry point, what kind of the name is applied to the entry point. For example, I can say entry point in Riga, and so I will name my type in the very same way. Important part is that there will be a field named card. It will have an argument, ID, and it will return a card. So we don't know what card is. We know what long is because it's a standard scalar type for our Java service, but we don't know about the card. So I will say there is a card, and card has an ID. The exclamation mark will point me that this is a mandatory field. It's always there. We'll have items, and there will be a multiple of them. This will be a list type. And also there will be a subtotal, which is a big decimal and also mandatory field. Since I'm lazy, I won't type the item fully. I will just paste it here. And the item for now will be very simple. It will not have a real connection to the product. It will just have a product ID, quantity, and total. We'll advance it further. I want us to move in stages, and this is like the simplest model we can get. So this is our schema. That's all we need for the schema. The next part is basically define how these fields will work, how the data fetching will work in the server. And for that, I will create a separate package for GraphQL stuff. So in this package, I will create a config, and this config will be a simple configuration class that is aware of the card service. Card service provides us fetching methods and saving methods for the card, and also HTTP client that will allow us to call product service and get the product data. I will introduce this horizontal splitter so that you, dear participants, can see the schema and the code at the same time. And the first thing that, the first problem that we have to solve in this API is how to get the card by ID. So we see there is a query type, which we have named arbitrarily. And for this query type, I have to introduce the so-called GraphQL query resolver. Everything you define in the query resolver will be used for fetching data as entry points to the graph. So in this case, there is a card field. So I will say there's a public method which returns card, which is named card. This is important. It will have an argument long ID, and I will just go to the card service and will find the card by ID. So this simple change would be enough for me. The simple function just tells me how to get the card, it will automatically work. But okay, card is simple, but what about ID, items, and subtotal? If you will go into the card, you will see that card already has getID, getItems, and getSubtotal methods. Since they exist already, I don't have to define them. So this is a simple like data class. And if I will go into the card item, I will see product ID, quantity, and total. So just writing one function in this particular use case will allow me and should allow me to define everything I need for my GraphQL server. So I will restart an application, and hopefully in here I will be able to execute the query like this. It will be a product ID, quantity, and total. So let me wait for the server to start. Here it's going. The server is started. I will refresh the GraphQL console. We'll run it. Boom, and it works. So everything is working now. I have the product ID, quantity, and total in every item in the cart. But of course, this is like dull. This is not interesting. I want to actually get the product itself. I want to say I want the product, and in this product, I am interested to get the title, the price, SKU, I want images. And this won't work because I don't have the product field defined. So let's make a next step and define the product field. This is going to be very easy. So everything we have to do, of course we can go to the cart item and write a method over here. But actually I don't want to change my domain because there is a need on the API side to return some extra information. So instead of doing that, I will go to the Java config and I will say, I actually want to create another resolver, but this time, not for the whole query. I just need a resolver in scope of the cart item. So in scope of the cart item, I will have a product field, and once that product field is fetched, I will go to my product service via HTTP and will return that data. So in schema, I will deprecate this field and I will say, please use product instead. I will add the product field, which is mandatory for the item. And of course, I will easily paste the product in here, which contains all the interesting data that we need. ID, title, price, images, SKU, description, everything like that. This change would be enough for me to enable a full-fledged server here for cart and product interaction. So I'm waiting for the server to automatically restart. I will refresh the screen here, and you see what happens. So first of all, the product ID is now underlined with this yellow line. It kind of hints me as a client that this field is deprecated. And if I will go to the docs, which is automatically fetched by the graphical console, because graphical console gets all the schema while it loads, I will see that in the item, product ID is not even suggested to me. So only the product is suggested to me, but product ID is hidden in the deprecated fields. All you see here in terms of UI, this is for free. This is like standard. You don't have to code it. You don't have to change it. It's available. It's developed by Facebook, and you can basically paste it into your web application, or you can link it via Spring Boot, as I have done here in this presentation. But most importantly, does this stuff work or not? So I will run the query, and I will see, yes, it does work. And I get all the necessary data that I was requesting. I can now remove the product ID because I don't need the product ID. And it's so far so good, right? So it was like maybe 5 or 10 minutes and we were able to develop a full-fledged server, but not really full-fledged so far, because I told you that for the images, I want to introduce the limit. And right now the server doesn't know about the limit. It always returns all the images. But since there can be 5 to 10 images, it's a lot of payload. Maybe I can also advance my API and return only the requested number of images. So let's do that. Also, a very simple change. I start with a schema. I say there is a limit field, which is of type integer, and by default it's 0, which means return me everything that you have. And then I will have another resolver. Again, this resolver is like this, is similar to this one, just works in the scope of the product, not of the cart item. And it has a parameter, limit. I will look at the images, and I will try to fetch as many images as the user requested in the limit parameter. And if the limit is 0 or it's too big, I will just return everything. Doing the compilation, doing the change now, and hopefully after refreshing this graphical console, I should see the limit not underlined with red, but actually not underlined at all, suggesting me this is a valid API to use. And you see this is the case. So now limit is kind of supported. Well, let's try to run it. You see, we have image in a single instance under images array. And if I go here and we'll say, for example, let's ignore this. I will comment out the limit thing and we'll run it. I will see all the images now. So now I can say this is pretty cool because I have developed a fully fledged API in 10 to 15 minutes against the microservices infrastructure, like 2 services talking together, using GraphQL. Everything is fancy. But there is one but. Let me tell you about the but. You see this horizontal splitter. You see like the process that we had here. I had to keep the schema and the code in sync. Every time I changed the code, I had to change the schema. Every time I changed the schema, I had to change the code. And this adaptation is not working for many people, for many engineers. So instead of doing that, what we can introduce, we can say, let us write just the code. And based on the code, generate the schema automatically. So I am removing the splitter. I don't need the splitter anymore. And I will show you the way to get there. There is a GraphQL speaker library. GraphQL speaker is not a completely new thing. GraphQL speaker, which means schema publisher and query resolver, builds on top of GraphQL Java. And what it allows you to do, let me show you it in the code. So in the code, you can see the following. I will open up the card graph, for example. You can say, okay, I have the query, which is named card. This is our entry point, and it supports the argument ID. And once it's invoked, this is the code I want to run. Easy and clear. Now the field will be automatically generated based on this annotation definition, okay? Let's take a look at the product graph. And product graph is also very similar. So I see the GraphQL query, which is a product, but it works in the context of the cart item. It's not an entry point into the graph. It's a field of the cart item. And in the same way, the images are defined. So at this point, I can actually remove the schema. I don't need it anymore. I can go and remove the Java configuration, and I can have everything auto-generated from this annotation-based bin definitions. So let me restart the application, and the result of this restart should be, if I run the query, we should see the same result basically. Nothing should change, okay? So it takes some time to build stuff and to run stuff, and I have to rerun the application in this particular case because speaker was added as a jar dependency. It was a new dependency, so we have to restart the server so that it will discover it. Let me refresh the page here, run the query, and I can see that it works indeed. And in the docs, we won't see entry point in Riga anymore, right? Because the query type was automatically created by speaker. We haven't defined it in our schema, so it's really the same. So far so good, and you may probably think that let's see how the query is run. You may think that maybe there is like some BMW inside. We have defined simple functions. Everything works out of the box. Seems to be fast and efficient and very, very performant. But let's take a look on the inside. So once we want to fetch the card by ID, we are actually going to the database, and we grab the item, both the card and the items in one SQL query. In this particular example, we're using the inner join to get the data. So it's one database request. But when it comes to the product, for every product, there will be a separate request. So for the first product, there will be a request to get the product 1. For the second one, product 2, product 3. And basically, you remember our card in the, at the start of the presentation, we had an n+1 problem between client and server. And now we have n+1 problem between one service and another service in our ecosystem. So basically, again, this is how our situation looks like. It was pretty positive so far, but something is not going well. So let's think how to address it. Before we think about, these are like the expectations. We thought there is a BMW, but it more looks like this. So any suggestion how to attack this problem? Use hints, maybe something else. So we can make something like a batch, okay? So we can, if our service would support fetching several products at once, and we, by the way, we can easily change it because it's the service in our ecosystem. It's not something external. So if our service would support that, we can basically collect all the product IDs when executing the query and get everything at once. By the way, I have to actually prove you that there is that this solution is not performant. I was running the Charles, the proxy, in the background, and if I will run the query, you will see there are 3 requests here with this contents. You see, so it's really unperformant. And at the end of the day, when we will make the changes, we want to see one request to get all the products. Okay, so let's fix this inefficient fetch. Let's address the n+1 problem between one service and another service. And the way to fix it is going to be the following. So we'll say, in GraphQL Speaker, it's very easy to get there. We will say, I want a batched request. And instead of fetching the product, I want to fetch the list of products. I will say products. I can rename the method in any way I want. The name doesn't matter, so I can say products whatever. And the fetch of the products will not be done in scope of one item, but in scope of several items. So I will say there is a list of cart items. I will call them just items. And now the request that I will use will be products IDs, and I will enumerate all the IDs I have here. And now we have to define the IDs. So the IDs is going to be a string. So it will be just a comma-separated list of all the products that I want to fetch. So I will take items. I will convert it to a stream. I will take product IDs from every item, and then we'll collect them, joining on the comma. So I have IDs here. I will insert them right here, and we'll get the products. So this simple change should get us to the place we want it to be, to have one fetch per cart to get all the products. I haven't actually shown you that this API actually works, so I have to prove that to you. Here we have the products, and for example, you see, if I will fetch all the products, I will get all of them. But if I will say, you know what, I actually want IDs, so like here, first ID and second ID, I will have only 2 in response, okay? So let's see if our stuff actually works. I will clear up the Charles, we'll run the query, boom, we'll go back to Charles, and I will see one request to get everything. Now, this is really nice because I can execute it second, third, and fourth time, and for each of those instances, I will have just one execution, one request sent to the product service. So this is pretty cool. But I'm still not satisfied. I'm still not there. What I would like to have at the very end, like let's suppose I don't need the whole product. I need just an ID, for example, or ID and title, okay? If I will execute this query and will go to Charles, I will still see that all product data is fetched from the product service. So still, in between one service and another service, it's not fully efficient. I'm still grabbing all the data from there. So in order to solve this issue, we can basically say that we can advance our product service and tell it, you know what, I want to support a particular fields on fetch. For example, I want to include ID and title only. So I will run the query, and now I will see for those 2 products only these 2 fields, not anymore. So suppose like we asked the developer to make this change, and this change was already done. Now let's take a look how to enable this on GraphQL API level. So in here, I will go and say, okay, I need actually access to GraphQL environment, and from this GraphQL environment, I need a set of fields that will describe me what kind of fields from the product are requested. I don't need everything. I want to work with the subfields. So I'll go here. We'll say I want to include the fields, and then I will join these fields again based on comma. We'll run the compilation, and hopefully at the end of the day, I will see now one thing going. One request going against the product service and fetching all the data. So I have run the query. I'm going to Charles. Boom. And now I see ID and title. And if I will change it, for example, to price and SKU, then here I will see price and SKU. So now this stuff is really efficient. Okay, let's talk about security, because security is a very important topic when it comes to GraphQL. So with security, let's think about it. Let's think about social network for a second. For example, there is Volodymyr's unicorn, and want to get his friends, names of his friends, and then friends of his friends, and friends of his friends. So basically, you want to get the whole Facebook out of this user. And of course, it will end up killing our server if we don't protect ourselves from this problem. And what happens here is we're giving to our client this. Does anyone know what this stuff is? Anyone play Doom? So this is a big fucking gun. So we're giving to our clients this big freaking gun that allows us to shoot into the server and potentially kill it. And of course, we need to protect it. And of course, this is the situation that we have right now, right? So again, everything was pretty positive. We have solved the n+1 problem. We have made the fetch between cart service and product service really efficient, but at the end of the day, something is wrong. And we need to limit the query depth. We cannot just, return all the data. This is one thing we have to do. Another thing we have to do is we have to limit the query complexity. What is query complexity? Like imagine that each field in your query has a weight, and you will basically collect the sum of all the weights and decide whether you want to run the query or you don't want to run the query. So let's defend from this particular attacks based on this toy example. I will go to my controller, and in the controller, when I construct my GraphQL environment, I can say I want to actually support max query depth of 3, which means everything which has a depth 4 and more will not be executed on the GraphQL server. So let's see it in action. This particular request has a depth of 1, 2, 3, 4. So this shouldn't go through. This shouldn't work. So, and when I run it, I get a stack trace and I get the message maximum query depth exceeded. So it's 4, which is greater than 3. And if I remove this and run this query, it will work. So this is one way to protect it. Of course, in the real production application, it may depend on what particular query is being run. So it may not be static, it may be dynamic. It's up to you to define. But now let me demonstrate another way to protect your server, which is max query complexity instrumentation. And this thing calculates the complexity for your query. For example, I will give 5 as an example here. And 5 will mean that if the sum of complexities of all the fields is more than 5, the query will not run. By default, every field has a weight, a complexity of 1. So here we'll have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if I will compile and rerun it, I think that this stuff won't work. So, but let's find it out. Let's find it out. The server should be restarted by now. Okay, the server failed to restart in this particular case, so I'll have to start it one more time. Okay, we're going back here. Okay, so now it's right. It says maximum query complexity is exceeded. 8 is more than 5. So now I can basically remove this field and this field, still keep the depth pretty big, right? The depth will be 4, but now this query will run because the overall complexity of the query is like 5 or less. This is a toy example, but what you can do, you can go and say, for example, in the product graph that, you know what, my complexity is actually a Java script, has a JavaScript calculation thingy here, and I will multiply 2 by whatever was calculated for all the child complexities. I can add 5, maybe multiplied by something else. So you can use pretty complex complexity calculations, and you can also make your own instrumentation. You can go to the GraphQL controller, and you can say, you know what, I want to introduce a chained instrumentation. I want to apply depth and complexity. And you can also go and define your own instrumentation, which has a lot of definitions here. So you can basically hook into the data fetch, you can hook into the processing of every field, and every framework, regardless of the language, provides something like this to like aid you in implementation of more complex stuff. And in addition to defending in this way, of course, we have to apply throttling and rate limiting. Wix would die if we wouldn't apply throttling and rate limiting, because there are DDoS attacks all the time. We have to set timeouts for every I/O operation that is happening against another service or against the database. It doesn't care. It doesn't matter. And also apply pagination. We shouldn't return all the data, even if it's like one field which returns, for example, contains users or products, and there can be hundreds or thousands of those. We have to apply pagination. GraphQL is pretty cool because it doesn't support only the queries; it also supports mutations. So you can not only fetch data, but you can mutate data. And in order to mutate, you have to put like you define a separate type, and in the separate type, you say, for example, I want to handle adding product to the cart. You say to which cart, which product, and in which quantity you want to add. And at the end of the day, there is a response type, which is also a cart. So after adding, you can actually go and grab everything that was added afterwards. Let us mutate. I don't want to write code for this example because we're running out of time, and it's not really interesting. So I will just scroll now forward in time. We'll check out the master branch. We'll restart the server, and in the meanwhile, we'll just show you how it is expressed in code. So in code, it basically says, I have a mutation over here, and the mutation is about adding the product to the cart. There are 3 arguments, there are default values, and once the mutation is executed, I just want to execute, for example, I want to run a method on the cart service. You can do whatever you want here. GraphQL console has a nifty feature which is called history, which in local storage stores the previous queries, and I can look up a mutation here, this one, for instance, and want to demonstrate you how that works. So in this example, we're adding the first product to the cart, adding 2 instances of those product. So when I run it, you can see that the quantity is actually changing by 2. And I can apply the very same querying rules as I had before. If I'm interested just in the subtotal, I can get the subtotal here. So it's pretty nice. At Wix, we're using Scala, and as I have mentioned before, there is like a Sangria library on top of Scala, which allows us to implement a GraphQL server, and we're using Apollo on the client. And lots of companies are now using GraphQL. So Twitter is using that, GitHub is using that, Facebook itself is using that, of course. Shopify, many companies are using that, including Wix. And you may think, okay, I want this thing. This is like really cool, and you have these GraphQL bubbles already in your mind, probably. But we're all engineers. We have to take a look at the sad parts. We have to see the bad parts of the technology. And in this particular case, in the case of GraphQL, we have to understand that caching is not really great because the more complex queries you have, the harder it is to create caches for that. In HTTP world and in REST world, there are intermediaries like gateways and proxies, which can basically allow you to cache the data on the middle level, not even on the client, not on the server, but somewhere in between using cache control headers and stuff like that. Nothing like this exists in GraphQL. So your caching, you will suffer from insufficient caching for this kind of API. You have seen that we need to solve new security problems with GraphQL. We have to limit query depth. We have to limit query complexity. We still have to be diligent in those kind of questions. The error handling will not be standard. It's going to be 200 OK for every GraphQL query. Now you have to look into the response. You have to find the error field. And this error field will not have some standard name. It won't be like 403 or 404 or 500. You will have to invent your own error names and communicate to your clients in a different way what each error means. It doesn't work with arbitrary resources and file uploads. For example, of course, you can get the image converted to base64 and pass it as JSON, but basically this is not the good use case for GraphQL API, as you can imagine. There is no separation between idempotent and non-idempotent operations. In HTTP, I had post, which is non-idempotent, and put, which is idempotent. And it was important for me to know that because idempotent operations can be retried. Non-idempotent operations cannot be retried. In this particular case, again, in GraphQL, the mutations, you have to provide that information in the offline documentation. Also, naming of operations. For example, delete case. In HTTP, I could say delete, and I pretty much know what that means. But in case of GraphQL, I should invent something. It should be either delete or kill or annihilate or terminate or whatever. There's no support for hypermedia, right? Because there is no links between resources. I cannot make this dynamic discovery. This is non-applicable for GraphQL. And you may think, and also like the most important part is it doesn't matter whether you are creating a REST API or GraphQL API, still the knowledge and experience of creating resources knowing which stuff to expose and what not to expose, understanding where there is a one-to-one and when there are one-to-N relationships, and many other questions related to API design in general, not specifically to GraphQL or REST. This is important. And there are alternatives in HTTP API world. For example, I can mention OData. OData was invented back in time, and it allows you to make this kind of elaborate queries against the API. There are even more complex things, not just includes and not just projections, but you can do more queries. There are filter support, lots of stuff. But it turned out it's not really popular right now. Only there is just a handful of tools that allow you to work with that in HTTP API world. But if you're looking into some features like having same kind of capabilities in HTTP API as you see in GraphQL, OData is one of the ways to get there. And before you decide whether to go GraphQL way or HTTP API way, I suggest you to read these two articles from the people who really understand on both practical and theoretical level what kind of differences exists in between two approaches. And you may think, no, I don't need this GraphQL API, I want to get back to the REST API. But before we go there, I have to tell you that GraphQL really shines as an integrated solution because in addition to the queries and mutations, there is a very nice thing called subscriptions. You can say, you know what, I, as a client, want to subscribe to events. For example, when the product is added to the cart. And once the product is added to the cart that I know of, I want to extract the items and subtotal. And then over WebSocket, once there is an event happening on the server will push message to the client, will notify it about the change. Since GraphQL is protocol agnostic, you can see here we have, like, by abstracting away HTTP versus WebSocket communication, we got this kind of capability out of the box, which is pretty cool. Or let's take a look at another last example in this presentation. This is Lee Byron, one of the creators of GraphQL, which shows a nifty feature called defer. So the nature of defer is the following. Imagine you are scrolling the Facebook feed. And the first thing you're interested in is basically the stories, right? Like who posted the story and what is the content of the story. And you're less interested about getting the comments right away. So you can express that in the query. You can say, I want author and messages right away. But at a later point in time, I am fine to get the comments. So you get a synchronous request response with initial data that you have requested. And then at a later point in time over the WebSocket, you can basically get the comments from the server. So this is like really advanced stuff. And if you're using React on the client, the integration is going to be very easy because both React and GraphQL are coming from Facebook. So this is an interesting approach to see and evaluate when creating a new API or when like advancing your API from a simple HTTP API to GraphQL API. And everything I've shown you today exists on the GitHub for quite some time. There is a Java implementation. I also have another talk, a similar one, about Scala. So if you're in Java or into Scala, you can take a look at the example on the GitHub. And I want to thank you for joining me today on this session. If you have enjoyed it, you can vote for me for the quality of content, speaker performance, and also leave the comment if there are stuff that you liked or disliked. And I really hope you also felt the positive energy I wanted to share with you today. And on this moment, I think we don't have time for questions. You can catch me right after the session, and we can talk about security, about stuff related to whatever you're interested in about GraphQL. Thank you very much.